Hello everyone. So in this lecture, I'll try to explain what is translation and how to implement translation in OpenCV using Python. So let's start today's class. First of all, what is translation? Translation means shifting of objects location. Okay, so the shifting of objects location, we do mean it as a translation in image processing tasks. Next, why we need to do translation. So we perform translation to improve the visualization of an image. Also sometimes as a preprocessor in application where we perform registration of two or more images. So first of all, translation is actually performed to improve the visualization of an image. You can visualize more clear way when we perform translation for some applications. Second, as a preprocessor when we perform image registration. Right. Then we can consider translation as a special case of affine transformation. Now, I know that this question arises to your mind that what is affine transformation, right? So don't worry, I'm going to discuss that. So affine transformation helps to modify the geometric structure of the image. You know, this translation and the other tasks that we have been discussing from the last few lectures, they are actually geometrical transformation of an image. So affine transformation helps to modify the geometric structure of the image, preserving parallelism of lines, but not the length and angle. So while doing the affine transformation, we preserve the parallelism. You know, by parallelism means parallel of lines. Okay. So we are maintaining the parallelism of lines, but you know, the lengths and angles, we are not preserving them actually. So it preserves collinearity and ratios of distances. So you may note it down that while performing affine transformation, or you can say translation, we are maintaining the parallelism, or we are preserving the parallelism, but we are not maintaining the length and angle. So in that sense, it means that we are preserving collinearity and ratios of distance. Now, this technique is also used to correct geometric distortion or deformations that occur with non-ideal camera angles. So you got it that why we need to do or why I need to perform affine transformation. Reason is that with this affine transformation, we can correct geometric distortion and deformation that may happen with non-ideal camera angles. I hope this is clear to you now. Now, let's come to our today's main focus point of discussion is that how to perform translation in OpenCV. In OpenCV, to perform translation, we are going to use this function cv2.warpAffine. As you got it that this is affine transformation, right? So for warpAffine function, we will perform transformation or sorry, translation. Okay. But here you have to define that shift. You know, translation means what? From here to here, you are shifting the location, right? So this will happen in both direction, that is X direction, right? And Y direction. So you have to specify that shift in X, Y direction. Now, we can make it into a numpy array of type np float 32. I know you all know about numpy array. I have discussed many times. And also, if you have not gone through those lectures, you can search it in my Python tutorial and those machine learning and OpenCV tutorials, right? So we are using a numpy array of type np float 32 and we'll pass it into cv2 warpAffine function. And here for this practical task of this video lecture, we are using a shift of 150. Got it? So I hope this is clear. Now, let me show you the code. Now, this is the code for this today's practical task of translation. You can take a screenshot of the same. So import CV2, import numpy as NP. You have just seen that we are using numpy array, and that's why we are using numpy. Now let's input the image with CV2 imread functions. But you see, I am using 0. You can comment me that why I am using 0 here. But let me remind you, let me give you the answer simply that we are using 0 because we are going to perform it in some grayscale. Right. Now, CV2 imshow, that is, we are showing the original image here. Now, rows and columns of this image. See, now this image with 0. Okay. Then, so from that, I can calculate the rows and columns with the help of this shape function. Okay, from the shape, I am retrieving actually rows and columns from this image. Now, M assign NP plot 32, I00 100 and 0I 50. Right. So that shift, don't forget that I have defined shift of 150, right? So that's why this statement we have included here. Now, everything defined. Let's now perform the affine transformation, that is translation. So CV2 work affine image, that image, then M, the shape information, and the columns and rows information from the shape of that image. Now this, with this, the translation being done, now let's display the output image. So you can image CV2 imshow, image DST, CV2 8 CV2 destroy all windows. So that's it. I hope that each statement is now clear to you. Now do remember that in the third argument of CV2 warpAffine is the size of the output image, and which should be in the form of width, comma, height. And you know that width means what? Number of columns, and height means what? Number of rows that we have got it from shape, right? Columns and rows. Is this clear? So that's it. Now I hope that everything is clear. Now you can perform the practical operations. Now you just open your OpenCV. Let me open mine one. So this one, I have named this code statements, the file as translation1.py. So everything being discussed, let me clear this actually. Okay. So import CV2, import numpy as NP. This is clear. This portion, I'm displaying the original image, but see, 0 is being used here. You can comment me that why I'm using 0 here. Then rows and columns information from this image with the help of shape. And then M for that shift operations with numpy array, plot 32, 100, and what? 50. So 10, 100, 0, 150. Then finally, we are performing this translation operation with that warpAffine and using the information from M and columns and rows that we have got from here. So finally, this translation done. So let us display the translated image with the help of this piece of code. Right. I hope this is clear to you. Let me execute this code for you. This is the original image. See, this is the original image. Now, this is the translated image. See, 150 is being transformed, and that's why this is the output. Right? You can clearly see that how the translation being done and what happened actually because of the translation. The image is being shifted to a new location, but parallelism is being maintained here. Yes. So I hope, guys, this translation information with this affine transformation, everything that I have discussed in this lecture is clear to you, do comment the question, answer of the question that I have asked, and let me know if any doubt that carry. So with this, Dr. Dibbo is signing out for today. I will meet you soon in my next lecture. Till then, take care. Bye-bye.